We will be starting with the second class where we'll be start working on drawing various parts from the 2D drawings that we will be having. So first of all, this will be our part, and will be what we'll be working with. So here we have our 2D drawings of our part. And the main thing that we need to see is the different views and the dimensions that are found in this drawing. So here we have our part, and those are the dimensions and all the information that we need to be able to draw the part. So before going into SolidWorks and start modeling this part, the first thing is that we need to have a plan of how we'll be creating this part. So in here, we can see that this is our part, and we can think of it as starting as some rectangular prism, a block of material, where we then will be able to cut the different features that are available in this part. This is one approach. Another approach is to go the opposite way, where we start extruding the material one by one from the beginning instead of starting with a block of a material and then removing different features. Both approaches are possible, and the one that you prefer more is also, you can choose the one that you prefer more. However, here we'll be starting first with the whole material, and then we'll be cutting the different parts. So we'll start first by cutting this area. After that, we'll be cutting this parallel part from it. After that, we'll be cutting this circle from this hole. After that, we'll be working on with this feature that has an inclined face. So let's start. We have our plan, and so we can start modeling. So here in SolidWorks, as we explained last time, you can start with the new, and then you can go to the part, and this will be what will have the first thing. To start, first of all, we need to always, with any 3D part, we'll always start from a 2D sketch. So we'll be going into sketch, and then we click sketch. Here we'll be given the choices of which plane we would like to choose for sketching. So if we check our part here, we can either start from this face and then we extrude it in this direction, or we could start from this face and extrude it this direction, or we could start again from the top rectangle and then extrude it downwards. So for this, let's start from this rectangle and then extrude it to give it some depth. So we can say that this is our front view, which is available here. If you orient yourself in this direction, you will be able to see that this is the 2D view that we'll be getting from this perspective. And so we can start from the front plane. Here we have the different types of comments that we have in the drawing or sketching mode. So first of all, we'll be starting with the rectangle. And so as you can see here, this will be our rectangle, and the dimensions can be taken from the sketches. So we can see here that we have the width is 3.25, and the height is from this view can be taken as 1.5. And an important thing is that in any 2D sketch, we have something that's called the title block, which has the necessary information to start the drawing, such as the project name or like the company name, the part name, the material, and the scale. And what is important for us now here is the units. So as we can see here, the units are in inches rather than in millimeters or centimeters, which is important because here in SolidWorks, depending on your settings, you may have different units. And so we can change the units of our SolidWorks from this view. So here it was on millimeters. However, as we saw in the sketch, we have inches. So we can switch to inches, IPS, inches, pounds, and seconds. And from here, we can again go into sketch front plane, and we can start with a rectangle as we saw. So after drawing our rectangle, we can see that some lines are blue while others are black. The difference is that the black lines are lines that are fixed in position. They cannot move or change dimensions, but the blue parts are still undefined. And we can also see at the bottom of SolidWorks, it's telling us undefined in this area, underdefined. And so an important thing is that before you get out or exit from any sketch is that you define all the dimensions necessary. And so we can go to smart dimensions. And as we saw here, we have the bottom part 3.25 inches. So we can simply click on the line, click, and then we can write 3.125, enter. With this, as we can see, this line became also black. And so we cannot, if we click and drag, we cannot move it. Unlike this one where if we click and drag it, we can move it. We can go again, smart dimension, and we can give this a 1.5, enter. With this, we have our sketch defined, fully defined, all the lines are black, and so we can go exit sketch, and then from here, we can see that the dimension that we want is depth, which can be taken from the top view in this drawing, which is 2.5. So what we can do, Control 7 for the isometric view, this is our sketch. To make it a 3D model, we go into features. We have here an extruded boss base, which simply changes a 2D sketch and extrudes it so that it becomes a 3D, as we can see here in this preview. So as we can saw, we want a 2.5 inches, enter one time. And then from here, I would like to have this extrusion on the opposite side. Here, you can press on this part so that the extrusion will go in the opposite direction. And here we'll be having different options that we'll be seeing later in this course. So after giving our depth of 2.5 inches, we can simply click on this green check mark or on this one. And with this, we have our basic part. And so as we saw in our plan, next of all, we want to cut this green area, which as we can see from here, after this is cut, we have at the bottom 0.75 inches from as a thickness for this lower part. So first of all, we'll be drawing this sketch at the top surface, and then we'll be cutting it 1.5 minus 0.75 inches, which will give us this dimension. So if we go here, we could click on the face, going to sketch tab and pressing sketch. With this, what will happen is that will be normal to that surface that we chose. And here we have the sketch options so that we can draw. So we can have a general idea of the shape that we would like to cut. And so we can simply draw this shape roughly. An important thing to see for is that as I'm drawing, as you can see, there are some various yellow icons that are appearing. Those are constraints. Because in SolidWorks, there are two ways where you can define any object or any sketch. So if you have, for example, this little triangle, we can define it in two ways. The first one is using constraints, and the second one is using dimensions. So the first of all of constraints is that we could, by clicking on, for example, this line, we will have here relations or constraints. Both names are used. So we could, for example, set it as a vertical line. And so this line would be always vertical. However, it can still be moved. And then the dimension of moving can be treated, or it can be defined by setting the dimensions using the smart dimension. And even though if, for example, here we have this triangle, for example, we have this 1 inch, this as 1 inch. Even though all the dimensions are specified for this triangle, we still can move it because we didn't provide its position in space. So we have all the dimensions, but what is left is that we need to define its position. So what we could do is that we could choose its vertex. While holding control, we can choose the origin, and then we have here another set of relations. For example, if we choose coincide, which just makes the two vertices at the same point, and so that both of them will be together and we cannot separate them. As we can see, the triangle now became fully black since we defined its position as well. So we can now delete it and focus on our main part. So as we can see here, we have this angle being 50 degrees. So we could simply smart dimension, select the lower part, this line, and then from here we could simply click and write our angle, which is in this case 50 degrees. With this, we set our angle, then we could go to those two dimensions, that 0.250 and the 1.250. So again, with the smart dimension still active, we could select this vertex and this and the origin, and we could click and then write our 2.5 dimensions. Again, at the top part, our 1.250. With this, as we can see, our part is fully defined as it's written here, and all the lines are black. We could again exit sketch, or if we would like to save time, we could directly go into features and we could directly choose extruded cut. What extruded cut does is that it takes a sketch and use it to cut a different object instead of extruding it as the extrude boss base does, as we saw earlier. So as we saw here, we are starting from the top surface and then we are cutting downwards. And so here, the dimension that is given to us is from the lower part instead from the top part. And so what we can do is that we could simply write 1.5 minus 0.75 to get this dimension. And we could calculate it, or we could directly write it into SolidWorks as 1.5 minus 0.75, and then we click enter. And here we can see the preview of our part. We click the check mark and then we have our first feature. And as you see, while we are going into creating the part, we have the different features that we created in this features tree. And at any point of time, we could simply drag upwards to cancel what we created. Or we could go forward to see what we created. And also if we right click, we also could edit the feature if for any reason we created something wrong or we want to change the dimension of the feature. After that, we can now define this hole and this slot. So we could click on this surface, sketch, and create sketch. Now we could have the two parallel lines that are available in the sketch. And it's important to check for the relations. If, for example, the line is in here, then this point would be able to move anywhere. However, if you see while I'm getting closer to the line, we have this yellow icon, which states that this point will be coincident with the line. And so if I release the left click, we can see this relation. And so the point cannot move right or left, but only on the line. And so this is one line, and then we need to have the other line. And with this, we have two lines. Here we can see that the distance between both of them is 0.265, and the angle is 45 degrees. So we could go to smart dimensions. We could dimension this as 45 degrees, enter. We could move this away. And instead of dimensioning this as well as the first one, the 45 degrees, we could again use relations. So if we click on the first line, if we hold control and click on the second line, we'll be having both of them selected as we see here, since they are highlighted. We can also see here that select entities, line 1 and line 4. And we can see here the different relations that are available for those two lines. And as you can see, SolidWorks recognizes what we might want to do. In this case, we want both of them parallel, and here it's bolded. We could choose it or any other relation, but in this case, we want them both parallel. And so with this, we can also see how these icons show up, showing that both lines are parallel. So no matter what I do to both lines, they will always stay parallel to each other. Then we could also use the smart dimension to dimension the distance between them of 0.265. Then we could also check from this sketch that we have the vertex or the end of the first line being 1 inch from the end of the object or sketch. So we could again dimension this with 1 and enter. Now both lines are black. However, there's an important thing is that if for example we exit the sketch right now and if we try to extrude cut it, what happens is that this feature of thin features gets activated. However, this is not what we want. We want this area to be cut. And this happens because if we edit our sketch, those two sketches are not connected. We don't have an area that is surrounded by those two sketches. And so what we need to do is that we need to connect the two ends of the lines in this side. And we do the same thing for the bottom part. And with this, we can see that the area is now shaded, which means that we have a closed shape that we could use later to extrude cut. And so here, we have now, as we can see here in this isometric view, a hole in here, and we can see it in here as well. And if we see in this front view, we can see its hidden features. We can see that it has a hole that has some bigger diameter, and then another one that is smaller that's going through the object fully. And we can see it in here. We see that the diameter is 0.5 and through, which states that the smaller hole, which is the 0.5 inches, is going through the whole thing. And then we see this symbol, which represents something that we call a counter bore, which simply shows that we have like a smaller hole and then a bigger hole that is cut into a lower depth than the one that is going through everything. And so we can see its depth is 0.35 inches. So we could go into the circle, click, and when we can go outside, click, and then we can do the same thing. Here we can see that while I get my cursor closer to the center, we see this yellow icon, which is a circle inside a circle, which simply shows that we have a concentric relation, which simply says that both of those circles will have the same center. However, let's say, for example, while drawing, we forgot or we drew it somewhere else. So what we could do is that we could select the center of the first circle and the center of the second circle while holding control. So now I'm clicking on control and then clicking the other center. We can see here the coincident relation, which makes both of them coincide, or we could select the circle and the other one, and we could use the concentric relation, which makes them have the same center. Now we could dimension both of them as 0.5 for the first one, and the other one that is bigger is 0.75. So this one would be 0.750. Enter. And so we have here, as we saw, we have the dimensions of both circles. However, they are still blue because their position is not defined, even though their side is defined. And so this is what we need to do. So as we can see here in this sketch, we can see that the dimension from this right edge is 1.625 and this dimension is 0.75. So we could go to Smart Dimension, click on the center on the lower line, and then we could go 0.75. And we could do the same thing for the other one, which is the 1.625. We could select this edge, we could select the center or the circle itself, and the same thing will happen. The center will be selected, and so this will be 1.625. So here we have our dimensions, and so as we can see here, everything is fully defined. All the lines are black. SolidWorks is telling us that the sketch is fully defined, and so we could exit the sketch. Control 7 to go to the isometric view. Then we could go with the extruded cut. Now what this wants is that it wants a sketch. If, for example, before clicking this, we already have the sketch selected and we extruded cut, it will automatically select it. But if we click outside and the sketch is not selected, then the command will ask us to choose a sketch that we want to use. We could use this shape to start sketching so that we will have our slot in here. And as we can see here from the front view, we can see that it is 0.25 deep. So we could come here and go 0.25 inches, enter. And as we can see in our preview, we'll be having our first slot. However, as you can see, after cutting using that sketch, SolidWorks automatically hides the sketch that we used. However, we want it back so that we can also create this feature of hole inside the part. What we could do is that we could go to our features tree. This is our last command. If we click on it, we can see the slot. We could click on the right arrow so that we will have a menu of the different sketches that this feature used, the extruded cut. So we could right click and using this eye icon, we can show the feature, show the sketch. So with this sketch shown, we could select the inner hole, extruded cut, and here we could put the dimension of 0.75 since this is the thickness of the part. But since here they say through all, what we could do also is that we could select instead of blind, we could go through all. And so this will create a hole that will go through the whole body. And so we could create, click the check mark, and we have here our hole. Control 7 to isometric view. We can select now the outer circle with the extruded cut again, and we can see here that our depth is 0.350. So we could go 0.350, enter. We can see our preview, and then we could simply go OK. But let's say, for example, we chose this circle and we clicked on the extruded cut. But what we want is that we want the outer circle to be chosen. We could go to this option in the extruded cut of selected contours. And here, this is the contour that is selected of the inside circle. So we could simply right click on it and delete it. And from here, we could select the outer circle that we want, and we could give it the 0.350 depth that we want. And with this, we have our holes done. We could now click on any part of this sketch so that we could hide it, or we could again go to the features tree and hide the sketch since we no more need it. So if we see our part here, we have almost everything done. The only thing that is missing is this face, which is an inclined face, as we can see here. We can see that it has an angle of 30 degrees. So for us to be able to do this, we could go using two different approaches. We could simply sketch using the right side view and then extrude this triangle, or so that we could learn a new command, we could use reference geometries, which are simply planes or axis points that we create other than the default planes and origin that SolidWorks creates, so that we could use them while creating our parts. So what we could do is that we could go into this and we could sketch simply this line so that we could use it to later define our plane. So we could go to the line and we could go simply like this. Then we could go to Smart Dimension. We can dimension this as 1 and clicking enter. And we could dimension this angle to be the 30 degrees angle that we want. The line is black, it's fully defined, and so we could simply exit the sketch. And so now if we go, for example, to the reference geometry and select plane, what will happen is that it will ask us for the reference points so that we could define our plane. And if we select this line, it gives us a yellow symbol which states that it is not fully defined, because for a plane to be defined, it needs 3 points, 2 lines, or it needs to have a line and a point to be defined. So what we could do is that we could create another line on the other face. So if we click on the face and if we go to the sketches tabs, sketch, we could draw the line again, or what we could use is the convert entities, which is a command that takes all the features or drawings from another sketch and puts it on the sketch that we are doing right now. So for us, right now we are using this face to sketch, and we have this line that we want to produce the same thing as it is. So we could click on this face, Control 8 to go normal to it. We could select this line, or we could select the sketch, and then we could simply convert entities. And so we have here our line. The advantage of this is that now if, for example, we have, for example, a different angle than this 30 degrees, what we could do is that we could simply change the angle of this line, and automatically this will change so that it will be always similar to this line. So we could now exit the sketch, and so now we have our 2 lines that we'll be using to create our reference geometry. So we could go again to reference, plane, we could select our first line and then our second line. With this, as you can see, it's fully defined. Here, there's a third reference since, as I said, 3 points also could be used to define the plane. However, here, 2 lines are enough and it is fully defined. And you can see here this line that shows the normal, which is how we will be facing the plane. So if we will try to sketch on this plane, what will happen is that SolidWorks will give us this normal view. However, if, for example, you would like to get this view when we are sketching, we could simply flip normal. So as we can see, the arrow changes direction. Then we could click on the green check mark and we have our plane 1. Now, with this plane selected, we could do the same thing as we did before, sketch. And SolidWorks will give us the normal view. However, let's say, for example, for some reason you want the other normal view, the one that had the normal in the other direction. What you could do is that you could control 8 again, and so it will give you the other side of the normal view, or you could press on this one. So this will just keep changing from one normal view to the other, since a plane will have 2 normal directions or perpendicular directions. And from here, we could simply draw a rectangle. For this feature, it is fine for it to be underdefined because what we want is we want all of this to be removed. So what we could do is that we could create a rectangle that is larger than our part. And this should be enough to create our feature. So if you exit the sketch, Control 7 isometric view, we could go to features, extruded cut. We could select the sketch that we created just now, and then we could simply cut the feature that we want. So we could change the direction so that it's facing the opposite way, and then we could go through all. If we click on the green check mark, we have our feature cut, and now we could simply hide this plane and the 2 sketches that we used to create that plane. And with this, we have our parts done. Like, to check whether, like, to make sure that everything is fine, what we could do is that we could simply change, as we saw in the first class, the style of display to this one, hidden lines visible. So we can see this one. And if we go through the different views, for example, Control 1 to go to the front view, we can see that both views are similar. We could do the same thing for the right view. Both of them are similar. And again, for the top view. And so from here, we could also see that we have a material, which is brass in this case. So what we could do with a Control 7 to go back to isometric, we could go back to the normal style, and then we could come here to the top of the features tree. If we right click on this part, we will have these options, and one of them will be material. And from here, we could choose the material that we want. Here we have brass, or if the material that you want is not available in these options, what you could do is that you could go to edit material, and here you have the full list of all the materials SolidWorks has. So we could have brass, and here we could simply click apply, close, and here we have our part. The advantage of having this adding material to a part is, for example, if you want to create it, or if you will create it, you want to have more ideas about it, what you could do is that you could go to evaluate, and then from here you could go to mass properties. And so here we can see that we have a mass for this part, which is 2.25 pounds in this case. This option is available because we have a material. If we didn't define a material, then SolidWorks will not have any idea about the density, and so will not be able to calculate the mass. And so if, for example, for any application you want to know how heavy your material is, this is a way that can help you to see how heavy a material is. And in this class only, for those who do not have SolidWorks but would like to follow this, the same commands and features are also available in other CAD software, as I explained in the first class. So just for now, we could see that we could do the same thing in Fusion 360. Here, for example, we could have a sketch. We could use this to draw the different dimensions that we would like. We could also dimension it. For example, here 150. We also have, for example, if we want to have the same parallel lines here. So Fusion 360 also has, for example, if we choose both lines, those are its constraints or relations in SolidWorks. We could also make them parallel, finish sketch, and it has the same extrude boss base, but here it calls it just extrude. We could select our parts and extrude them, for example, here 30 degrees, 30. We could show the sketches, and we could again select this profile to go, for example, at 10. So as we can see, all CAD software would have the same thing, but as we saw, they will have different names, different looking, and they will be somehow different. So it will be up to you to try to find the different commands in the software that we'll be using. However, most of the time, all the features will be available, and it will just need to have a little more work so that you can translate from the commands that we'll be using in SolidWorks to any other CAD software that you will be using. And that's it for now. If you have any questions regarding this part or anything, you can feel free to ask.